wanted to try out a quick bit of mining and modeling. We wanted to basically look at what defines insurance prices across the country. So we've got about 1,338 cases where it goes into age, the sex of the person, the BMI of the person, how many children the person has, whether he or she is a smoker or not, region of the country, and the insurance charges. So in this case, we're not going to worry too much about the region of the country. Let's assume they're all distributed equally, and then we'll remove that. So we're basically trying to say, do charges depend upon whether you're a smoker, whether you how many children you've got, your BMI, your sex, and your age. Now, you'll see that things such as sex and smoker have text in them, as sex being male or female, smokers being yes or no. So we've got to figure out a way to first convert that into a numerical value. So in order to do that, what I'm going to do is go up into Excel and go into Insert, Columns, and it adds a column there. Similarly, with smoker, I'm going to insert another column, adds a column there, and then we'll name it again as sex and as smoker, and we'll try to replace it with a numerical value of sorts. So let's assume female is 1 and male is 0. So what we're going to do is we're going to use a function called an if function, or a conditional function. Say it's equal to if bracket this cell is equal to, says female, so whenever it's a text you've got to put inverted commas around it, female, and then comma, so it says if C2 says female, then mark it as a 1, else mark it as a 0. So once again, it says if cell C2 says it's female, mark it as a 1 or else mark it as a 0, and we'll click enter. And you see that cell C2 is female, so it's 1. Now if you were to pull it to the next one, the cell C3 is male, therefore it marks it as a 0. So using this whole logic, you can just hover your mouse around the corner where it turns into sort of a crosshair, and then double click it, and voila, you've got everything filled in for you. Next, we'll do the same thing for smoker. So we'll say that if you're a smoker, then mark it as a 1. If you're not a smoker, you're a 0. So is equal to if this cell is equal to a yes, because it's written as a text, you've got to put it within inverted commas, then it's 1, else it's 0. And there you have it. Click it, same thing, crosshairs, double click, and it converts it into whatever it is. If it's no, then it's a 0. If it's yes, it's a 1. So that's a quick way of converting a text into a particular numerical value. Now here's an interesting thing. In order to run a prediction model, you need to select the whole set, but you've got these male, female writings and smoker, yes and no writings all over the place. So it's going to have a tough time figuring out what you want to calculate and how anyway. So we'll have to get rid of it, so we only want numbers. But here's the tricky bit. If we were to simply delete this section, because this references this section, it'll suddenly say, oops, I don't know what just happened, and go bonkers. So what we want to do is we want to copy this again, and then, so we copy this as Control C. Then what we do is we go into Edit and go into Paste Special, and only put in the values, which basically means it will only remember the values rather than what it's referencing. And click OK. And we've got the values in there. which means that now if we were to delete this entire column, that doesn't change. So we've now basically successfully replaced the textual values with numbers. Similarly, what we'll do is copy this part where it's a numerical value for sex, go into first copy it, then go into pay special, only the values, and then click OK. And now we hopefully can safely delete the text markers. So we've got this a bit in order. So once again, it has age, so let's make sure that they all look similar with the first letter in caps. BMI, children, smoker, and insurance charges. So once again, we want to look at whether insurance charges are affected by whether you're a smoker or not, how many children you have, what's your BMI, your sex, and your age. At this point, the first thing to do would be doing a quick example of our quick plot in terms of how do we stand? What's the general BMI of these 1,338 observations from which we've collected data. So what we do is we go onto BMI, and then we, on a Mac, you can, instead of highlighting, going through all of them, if you've got a very long file, it becomes more difficult pulling all these things. And so what we do is Command, Shift, and press the down arrow, and it'll select right up to the end automatically, which is 1,338 values. So if I were to carefully go up, you'll see it's 1,339, and the first row is a label, which means it's got 1,338 values or observations. So once we're there, we say, all right, let's try and insert a chart. Let's start off with a scatter to see how it looks like, and there you see it. This is the scatter chart of BMI, and this is the number of observations you see. Some in the range of 50, few of them. Most of them seem to be concentrated between what do we say, about 22 and 40. Now it might look very cluttered, but get a general sense. You might want to even change the chart type to look at a histogram, turn it into a histogram, so that you've got a better sense. Cleans it up a bit. And now you're saying that you seem to have most of them, it's not right in the middle, which basically means that it's positively skewed, right? So things tend to be pressing a little to the left, which means in general, the BMI appears to be little on the lower side, the average BMI, rather than on the median side or on the higher side. So that gives you a general idea of this is a chart for the BMI. So let's see if I can change the set out there. Go into chart title. And then that's a BMI. So that gives you a general sense. The next thing to do is, now that we've been able to visualize, so you'd be able to visualize any of these bits if you want. But let's get cracking and let's see how the descriptives generally run. So let's do a quick descriptive. We want to see an overall view of the general data. So we'll go into data, and then under data itself, say here's data, go into data analysis, and we'll start off doing a basic bit of descriptive statistics. And click OK. And now it's saying, what area do you want to cover? And we're saying that, all right, we're going to cover from A1 to F1339, making sure that the labels are in the first row, and we'll output it right out here because we want to have a quick look. So we'll say, let's say that the output range is, output range out here is there. So once again, your input is from A1 to F1339, of which the first row is a label row, and we are outputting it onto the same page, H18, and then we click OK. And you let it run. And then you've got this info that's calculated for you. You see that for each of them, it tells you that the mean BMI is about 39.207. Now, it's interesting. It basically says that the mean sex is 0.49. Now, if you remember, females were 1 and men were 0. If they were exactly equally distributed, then it would have been exactly 0.5, which means that there's slightly more females in the population. Not much, but it's a well-balanced population. Because if there were more men, many more men, then it would have moved closer to the lowest set. And in this case, you're saying that that's the main set, right? So with BMI, you see the average BMI is, the average age is about 39.207, I'm sorry. Sex, we talked about it, BMI is about 30.663. Mean of children is 1.09 children, and mean for smokers is about 0.204. Once again, if you're a smoker, you're 1. If you're not a smoker, you're 0. It tends to be closer towards 0 than towards 1, which basically means that most of the people tend to be non-smokers. And then your mean insurance charge seems to be about 13,270. Right, and this I think comes from like an entrepreneur data set, and that's why you see that the insurance charges are like that. Then again, you're talking about standard error, but mainly let's focus on the standard deviation. Standard deviation tells you the variance, and the greater the variance, the greater the standard deviation. You also see that total count, as we had mentioned previously, was 1338. Skewness, which is whether it's positively skewed or negatively skewed. Once again, if it's negatively skewed, then most of the data lies towards the right side. If it's positively skewed, most of the data will lie towards the left side. In this case, from a quick look, you can say, hey, the data seems to look like it tends to be pushing towards the left. So we could somewhat say that, all right, it's a positively skewed data set. And as you look at it, you'll see that, all right, yes, it is a positively skewed data set, and that gives you a general sense of the data. Going forward, without getting into too much detail, we now want to look at how are they correlated amongst each other. So once again, we'll sort of rely on Excel's data analysis, go into data analysis, and now we'll choose something called correlation. And we want to see how they're generally related. We're not predicting, we just want to see the general relations. And once again, the input range is from A1 to F1339, labels in the first row, output range. Now, where should we keep it? Let's put it somewhere right out here so that we have quick sense of how they stack up. So we're saying let's output it on N1, and we click OK. And let it do its calculation. I'm sorry, I've got too many windows and it's a bit slow. And now you've got your correlation. Now, all correlation shows is that it's bivariate. So it says if one moves, how does the other one move? So in this case, we're saying what's the correlation between age and sex? And the answer to that is the correlation is a very, very, very low correlation. It's about 0.0208. What's the correlation between BMI and age? Which basically means that as it's 0.109, which you would say that as age goes up, BMI also tends to go up. Or as BMI goes up, age also tends to go up. What's the relationship between BMI and sex? And again, if it's female, it's 1. So the negative relationship is as you're moving from 0 to 1, your BMI seems to be dropping, which means as you move from being a male to a female, BMI seems to drop. So which you could infer that females tend to have lower BMI than males. Similarly, if you look at age and children, there's a slight positive correlation, which basically means that with increase in age, you increase in the number of children. Similarly, you have got a negative correlation between children and age, which seems to show that there's a very, very low correlation, although it's a negative one, that shows that females tend to be having, or female-owned companies tend to have fewer children in general. Similarly, with BMI, you see children and BMI have a slight positive correlation. Similarly, if you want to look at smokers and age, you see that as age increases, again, smoker is 1, non-smoker is 0. With increase in age, so as you move from going from 0 to 1, it tends to drop, which means that younger people tend to smoke more or slightly more than older people. Same thing with smoker and sex. Seems to be that men, which is 0, and females 1, tend to, because it's negative, tend to be more smokers, or more men tend to be smokers than females. With BMI, it says that your BMI is positive between being a smoker but slightly positive, which means people who tend to be smoking tend to have a slightly, negligibly lower BMI, or negligibly higher BMI. And children, also a very, very weak link between smoker and children. If you're a smoker, possibility of you having had more children is slightly higher. Now we get into insurance charges. This is a very interesting bit. Look at the one that has the strongest relationship between any of these categories. It says if you're a smoker, the relationship between insurance charges and being a smoker is massive, 0.78. Which one's next? Next one is age. Insurance charges and age also seem to have a strong relationship. So insurance charges seem to go up based on whether you're a smoker, then based on your age, then based on your relationship. Again, sex, 0 is male and 1 is female. So as you're moving from being, or as somebody's, if you're moving the data set or comparing it from male to female, your insurance charges seem to go down if you are basically a female. So that gives you a nice quick overview of the general relationship between the data bits. Now we want to get into doing a little bit of prediction. In order to do that, we go back into data analysis and we get into regression. That's your prediction modeling. And we click on OK. And we're doing basic linear regression. And we're saying, all right, what do insurance charges depend upon? Or to what extent do insurance charges depend upon age, sex, BMI, children, whether you're a smoker or not? And in order to do that, we say, what's the Y range, which is your main area of improvement or what you want to examine in the first place. And you say, all right, it's F1 to F1339. And what's your X rate? You say, that depends. So insurance charges will depend upon age, sex, BMI, children, smoker. So we basically say that, all right, this whole set, so if I were to do it again, I'll just cover just a tiny bit, but instead of putting in all the numbers, I can just copy 1339, or I can do Command Shift down K, and that'll automatically find 1339 for us. That's where you've got a data set with hundreds of thousands or possibly millions of observations. You can quickly go right to the end observation without scrolling for years trying to figure out exactly where that is. And then we say, all right, we have labels, so all we are telling Excel is don't think that the first line is actually a value line. So just focus on everything that follows thereafter. And then it comes into where should we output it. Now, let's output it a new worksheet ploy, just to keep it less cluttered. And say new output ploy, and now let's and once again we're keeping our confidence level at 95% confidence, so we want to say that our prediction is going to be at a 95% confidence level, which basically means that 1 minus your confidence level is your level of alpha or level of significance, and your p-values must be less than your level of significance for you to say that, hey, it statistically makes sense. So let's actually do it before we jump 2 paces further. Click OK. And wait for it to do its job. And you should see a new worksheet open up, which is this one. Calculates the regression, and let's do a little bit of housekeeping and call it the prediction sheet. And there we have it. Adjusted R-square. You could also look at the R-square. I personally like the adjusted R-square because it takes care of some level of redundancy if there are things that are very similar to each other, but you see the data seems to be good enough that the R-square and the adjusted R-square are very similar to each other. Now, what on earth does that mean? It says that the adjusted R-square is 0.7487, so let's say 74.88%. So this basically means it's about, so if we are to this times 100, right? So we're converting it into a percentage basis. So we're saying that, what does this mean? It means that age, sex, smoke, BMI, number of children, and what was the last one? Let's go back for a quick look. I'm sorry, I just forgot. And whether you're a smoker or not. And smoker explains about 74.88% of the variance in insurance charges. So that's what it does. It explains about 74.88, which is pretty nice there. You're saying that it explains about 75% of insurance charges based on these sets. Now the next bit of the puzzle is understanding. So once again, you see that 1,338 observations. Now you start looking at this very important piece called the p-value. And let me see if I can find a way to mark it for you. So the first one that was very important was that, and let's highlight it using that. Next part is knowing the p-value, which tells you what we want to predict. Are the predicting or the predictors significant or not? So that's a very important piece before you embark upon anything else. And we try and look at this bit to see, are these values less than 0.05? Remember, we used a 95% confidence interval, which means your level of significance is 0.05. A rule of thumb, these values ought to be less than 0.05. So even if we were to jokingly say, create an if statement where you say, if this number is less than 0.05, then say type significant, if I've spelled it correctly, significant, and then close it. Else type not significant. So, and then just make sure that the first letter is also in caps. And then let's see if that works. So we are saying that if that is less than 0.05, significant or not significant. And we say, all right, it's significant. And then we carry it forward across all the predictors, and it says, wait, there's one that's not significant. So let's start figuring out what they mean. Which one isn't significant? It seems to be sex, which basically tells you that insurance charges aren't related or aren't driven by the sex of the insurance applicant, but rather by other things such as age, BMI, how many children you have, and whether you're a smoker or not, which is interesting to note. The next piece of the puzzle is, all right, so we've got this bit, and then we'll also mark it in the same color so that you know that's related to it. The next more very important piece is the piece about age. Sorry, the piece about something called coefficients, and let's mark that. And let's create this for it. So we're saying that's coefficients. So what exactly do the coefficients mean? Coefficients basically, just like doing a first order differential, it's basically a dy by dx. So what's your y? You're saying how much do insurance charges change based on each of the x's. So if you're doing a dy by dx as a first order differential, you're saying, all right, let's look at age. You would say that for every for one year increase in age, insurance charges go up by $257.73. Similarly, you'd say for sex is not significant, so we're not going to worry about that. Assume it were significant, we would have said that as sex moves from 0 to 1, which is 1 is female and 0 is male, the person who's male is likely to pay $128.63 or $64 less than females. So insurance charges appear to be higher for females by about $128.64. That's only if it were significant, but it isn't. What about BMI? We would say that, all right, for an increase of 1 in BMI, or as BMI increases by 1, insurance goes up. Let's say insurance goes up by $322.36. Similarly, having more children appear to be more expensive as for insurance. So having one more child will increase insurance by how much is it? $474.41. And finally, whether you're a smoker. Remember the high correlation between smokers and insurance charges. If you are a smoker, insurance charges. Now do realize these insurance charges are over a period rather than per year. Charges go up by a massive amount, which is $23,823.39. So it certainly gives you a quick overview in terms of what's important and what's not, and not only what's important. So we know that age is important, sex is not, BMI is important, number of children important, and smoker, whether you're a smoker or not, that's important in order for you to get a good idea of how much insurance or what insurance companies look at. The next question is, how important is each? And we see that smoke, whether you're a smoker or not, is the most important of the lot. Followed next by how many children you have. See, that's 474. Followed then by your BMI, followed then by your age. So this is how insurance companies seem to prioritize in terms of how they even end up calculating insurance charges. Now, we're not going to use this for prediction right away, but this is where I'll stop so you've got a general sense of how to look at a data set and how to get a brief idea. After this, we'll try and do something in terms of predicting based on, so you can say that, all right, if somebody has a certain age or a certain sex, as you know, in this case sex is not significant, or certain BMI, if they have a certain number of children, if they're a smoker or not, what should be the insurance that we should charge them over a period? And that's what we'll get to next. Thank you very much, guys.